React.js, as a very important front-end library, has been continuously optimized for UI rendering on the JavaScript side of the browser. Recently, the latest React 18 has released an alpha test version. Among them, there is an important function, concurrent mode. Today, we will talk about the concurrent mode of the front end and some of the changes it can bring. Of course, it is only an experimental feature. The official version may be a little different. In the operating system, there are two modes, concurrent mode and parallel mode. Parallel mode means that multiple CPUs execute a corresponding number of processes at the same time. However, if there is only one CPU, multiple processes, or the number of CPUs is far less than the number of processes. In fact, this is the normal state of our computers today. Then there will be multiple processes sharing the same CPU. However, in order to allow these multiple processes to proceed simultaneously, it is necessary to let the CPU continuously rotate execution. Each time it is executed for a short period of time. Therefore, in reality, only one process is executing at a time. However, because the rotation is so fast, to the user, the processes seem to be proceeding at the same time. This is concurrent mode. So, does this have anything to do with JavaScript in the browser? In the browser, the rendering of the screen requires two parts. One is the rendering code inside the browser written in C++, and the other is the JavaScript front-end code, which communicates by calling the DOM interface. The whole process is a single-threaded. Even if there are multiple CPUs, parallel computing cannot be achieved at the JS front-end level. Note, though JS now has workers to implement multi-threading, however, they cannot directly call the DOM interface, so they cannot be used for rendering and can only used for pure computing. Therefore, the React team implements a concurrent mode at the JavaScript level to achieve similar effects. So, is there any benefit to the front-end concurrent model? For example, there is an input box in a web page, and there is a very long list. When the input box is typing, this long list needs to be continuously rendered. At this time, the input will become very stuck. Why? Because the execution of JS is single-threaded. Therefore, after importing once, the input box and the long list need to be rendered before the new input data will be processed. Then, before the rendering is completed, the newly input event will be temporarily saved and wait, which greatly affects the user experience. Therefore, React.js proposes to build a concurrent mechanism at the JS level. Let the rendering of the input box and the rendering of long list are handled separately, although this is actually single-threaded. First of all, if you want to use the concurrent mode, you no longer use the React DOM.render interface. You need to use create root. The difference between them is not specifically introduced here. To put it simply, the virtual DOM tree constructed in the original render is attached to the root node. Now about the root node, an object is created separately, and then its render interface is used. Well, let's look at two examples. One is the use of suspense components, used for processing I/O time consuming UI components. The other is to use start transition in hook use transition, which is CPU time consuming. Friendly reminder, from here on, basic knowledge of React.js is required. This is a React component we need to read the value of user from a resource and render it as a headline. Then this resource needs to be obtained from the server through the network. Therefore, we need to execute a function first. Because network transition takes some time, the resource returned must be a promise. So the question is, how can this promise directly extract the user's name attribute? React provides a new component called suspense. It wraps components just now as children. Then a default setting is required. That is, when the promise has not been resolved, that is, before the data is extracted, information such as loading is displayed. When the promise is over, the profile details component will be rendered. In this way, our profile details component can directly treat the promise as a normal return value. In the second example, this is a component called app. A button and a complex component called profile page are rendered inside. When the user clicks with the mouse, the profile data will be obtained from the network first, and then the state of the resource will be set, which will trigger the rendering of the entire component of the app. Here, although the page is not refreshed during the I/O process, the page that is waiting to be loaded is avoided. However, the rendering of the component profile page consumes a lot of CPU time. Therefore, the users will need to wait a while when the component is rendered. Then React gave a new hook function, use transition. The start transition it returns wraps the onClick callback function of the mouse. At this time, React will let the new profile page component render in the background. It is still the original profile page that faces the user, and it can still be interactive. Wait until the new component is rendered, and then refresh. In addition, this pending variable here gives the current state, whether it is rendering and loading in the background. The final effect is this. When the new screen is rendered in the background, the current screen will be displayed and a prompt will be given. In general, in the concurrent mode, UI components are contained by suspense components. Let the loading and the rendering process of UI components proceed in the background, and currently display fallback components. The start transition contains a callback function, so that the new component page is rendered in the background, and the original screen is displayed. After everything is done, the new component will replace the current displayed component. After the alpha version, there are beta, RC, and other versions, and it will take a few months to wait for the final 18th official version. The current specific information may still change, so do not use in the actual production environment for the time being. Okay, this is all for today's video. See you in the next issue.